We coming home.
Assalamualaikum warahmatullahi wabarakatuh to our lecturer, Dr. Aini. Today in our video, we would like to present our project, which is application of linear algebra in traffic flow. There are 4 members in our group, including myself. My name is Maisarah Bt Abd Sukor. So here is
Hi, I'm Amirah Bt Abu Bakar, and here is.
Shazwina Amirah Bt Shamsuddin. So the next is
And my name is Hanisah Bt Johar. Okay, we will start our presentation now.
Okay, let's start with the introduction. First of all, I will explain a little bit about linear algebra. Linear algebra is central to almost all areas of mathematics. It also used in most engineering areas because it allows modeling many natural phenomena and efficiently computing with such models. In our project, we want to study about traffic flow. What is the traffic flow? Traffic flow is the study of interactions between vehicles, drivers, pedestrian, and infrastructure with aim of understanding and developing an optimal road network with efficient movement of traffic. From that, we want to know how many cars through for every road if there is intersection between each of them. So, we need to apply linear algebra to solve this problem.
next is problem statement. Diagram below represents an area of downtown Batu Pahat, Johor. The streets are all one way and the arrows are the flow of the vehicles. The flow of the traffic in specific area is measured on terms of vehicles per hour in and out of the network. The diagram below shows the 4 one-way streets in Batu Pahat. So here, we have 4 streets which is W, X, Y and Z, and there are 4 traffic in them which is A, B, C and D. In the diagram, at A, there are 110 vehicles per hour that enter the intersection and 205 vehicles per hour that leave. At B, there are 120 vehicles per hour that enter the intersection and 180 vehicles that leave. At C, there are 220 vehicles per hour that enter the intersection and 130 vehicles that leave the intersection. And lastly, at D, there are 105 vehicles per hour that enter the intersection and 160 vehicles that leave the intersection. From all the information given, the numbers of cars going through in and out can be found. So the question is, from the figure shown, shows the calculation of how many cars that going through the intersection, which is flow of the traffic, in terms of vehicles per hour, VPH, for every streets X, Y, Z and W if there are intersection or traffic between them.
So now we will start with problem solution. For problem solution, there are a few assumptions that were made in order to find the vehicles per hour in the flow of the traffic. The first assumption is the number of vehicles that entering every intersection are equal to the number of vehicles leaving the intersection. And all the streets are one way and the arrows show the direction of the vehicles. The third assumption is total number of vehicles that entering each intersection is equal to the number of vehicles that leaving the intersection. So based on the model and assumptions, the system of linear equations are made. Traffic in equals to traffic out. And for intersection A, 110 plus W equals to X plus 205. For intersection B, X plus 180 equals to 120 plus Y. For intersection C, 220 plus Y equals to 130 plus Z. And lastly, for intersection D, 105 plus Z equals to W plus 160. From all the intersection, we will get this linear equation, that is W minus X equals to 95, X minus Y equals to negative 60, Y minus Z equals to negative 90, and Z minus W equals to 55. Then, to solve the system of equation, we use Gauss-Jordan elimination method. We use Gauss-Jordan elimination method to solve the system of equation because this method is to find the form of reduced row equation. By solving the row reduced equation, number of vehicles passing through a street can be identified. So, from the Gauss-Jordan elimination method, we will get this system of equation, that is W minus Z equals to negative 55, X minus Z equals to negative 150, Y minus Z equals to negative 90. And then we will move variable Z to the right hand side of the equation and we will get W equals to Z minus 55, X equals to Z minus 150, and Y equals to Z minus 90. The system of equation will have many solutions, but the traffic variable must not be a negative value, as the negative value will be interpreted as traffic moving in the wrong direction on a one-way street. Thus, the smallest value of Z that we can assume is 150. If we take Z to be 150 vehicle per hour, then the value of W equals to 95 vehicle per hour, X equals to 0 vehicle per hour, and Y will be equals to 60 vehicle per hour.
So, the conclusion is, by using Gauss-Jordan elimination technique, we can calculate the number of vehicles passing through the street. When the number of vehicles on the road that passing through the street is known, then the traffic can be controlled. Thus, from this problem, we can conclude that in order to have a smooth traffic flow without having jam in downtown Batu Pahat Johor, we can assume that if the limit vehicles that can be routed between C and D is 150, then 95 vehicles per hour must be routed between A and D, while no vehicle routed between A and B, and lastly, 60 vehicles between the intersection of streets B and C.
So that's all from us.
Thank you. Thanks for watching.
Like and subscribe.